All right, today we're going to talk about simplifying radicals. So some of you might have done this back in Algebra 1, so this is hopefully a review. If you have not, that's okay. This is relatively simple to catch on. So first off, a radical is an expression with a square root, a cube root, a fourth root, anything like that. The radical symbol is what looks like this division sign here. That is the radical. The number inside is called the radicand, and then sometimes there's a little number in the corner of that radical symbol. We call that the index. If there is not a number there, then your index is 2, which means that it's just a square root. Okay? So here's how you simplify. So there's two cases that you might run into. The first case is where you have a perfect square. These are numbers like 1, 4, 9, 16, 25. Those perfect square numbers, you just take the square root, okay? In the second case, if it's not a perfect square, you will break down the radicand, so the number on the inside, until you find pairs. The pairs move outside the radical and the leftover stays inside. And I'll talk about that more here in just a second. In both cases, if there is a coefficient outside the radical, multiply this with any number you take out. Okay, let's look at an example. Our first example here is the square root of 49. So the square root of 49, that is a perfect square. That is going to equal 7. Okay, same thing with the square root of 144. That is a perfect square of 12. Now, let's look at a different form. If we have the square root of 1 over 81, I can simplify this to the square root of 1 over the square root of 81. Well, the square root of 1, that's a perfect square, that's 1. The square root of 81 is 9, so that is 1 over 9. Now let's look at whenever we don't have perfect squares. So let's take the square root of 112. We are going to break this down into factors. So two numbers that will multiply to 112. I know that 4 and 28. Okay, so 28, I can break that down even more into 4 and 7. Now I'm going to stop here because if I am taking a square root, I need groups of 2. I need pairs. So two numbers that are the same, I have a pair of 4s. So those will actually come out of the square root as one number. So this will be 4 times the square root. Now we take the leftovers. I cannot break down 7 any further. That is a prime number. So I can't break it down any further than that. So that is the leftover that stays inside. So this simplifies to 4 square root of 7. So now let's take a look at number 5 here. We have 3 times the square root of 250. So remember, anytime that you have a number on the outside, any pair that you take out, you will multiply by that number. So let's break down 250. I know that that is 25 and 10. I can break down 25 into 5 and 5, and 10 into 5 and 2. I'm looking for pairs. I have one pair of 5s. Now this 5 is all by itself and this 2 is all by itself. So I put those in boxes because they stay inside of the radical. So this 5 will come outside as one number. And remember, we will multiply the outside. And then the leftovers on the inside also get multiplied as well. So 5 times 3 is 15. 5 times 2 is 10. So this simplifies to 15 square root of 10. Let's look at number 6 here. We have 5 square root of 72. So 72 is not a perfect square. I'm going to break that down. I can get 9 and 8. I'm going to break 9 down into prime numbers, so 3 and 3, 8 into 4 and 2. So I have one pair, but I can go further with the 4 here into 2 and 2. Now, look at your bottom row of everything. Okay, that's where you're going to find your pairs. So I have a pair of 3s, I have a pair of 2s, and I have 1 2 left over. So 1 3 will come out, 1 2 will come out, and then a 2 will stay on the inside. So I will have 3 times 2 times 5 square root of 2. So 3 times 2 times 5 is 30 square root of 2. And that's how you simplify radicals.